Hello everyone, and welcome to another video in my channel. I have a very interesting integral problem to solve. I have 1 over x squared square root of 9 minus x squared dx to resolve. How do we go about resolving problems like this? It looks complex, but there is something I've discovered about integral problems. If the denominator comprises sum of squares or difference of squares or even the square root, and what we have under the square root is the difference of two perfect squares, we normally use trig substitution. So in this problem, I'm going to let x equal to 3 sine theta. Now I'm putting 3 here because 3 is the square root of 9, or 9 is the perfect square of 3. So you will see that this substitution is reasonable for this problem. However, I'm going to differentiate this. So dx d theta is equal to 3 cos theta, and let me make the x the subject because I need to substitute this dx here. So dx is equal to 3 cos theta times d theta. Again, let's remember that sine square theta plus cos square theta is equal to 1. If I multiply through by 9, I have 9 sine square theta plus 9 cos square theta. It is equal to 9. So if I factorize 9 out, the 9 here will cancel the 9 here. So let's make this the subject. 9 cos square theta is equal to 9 minus 9 sine square theta. Again, let us reduce this into a simplest factor. So 3 cos theta all squared is equal to 9 minus 9 sine square theta. Now 3 cos theta is equal to the square root of 9 minus 9 sine square theta. We can rewrite this as 9 minus 3 sine theta all squared. Good. Now let's remember that 3 sine theta is equal to x. So I'm going to put this, or rewrite this, as square root of 9 minus x squared. And that is our 3 cos theta. Very good. So I will come here and write 3 cos theta instead of this. So our problem can now be rewritten as integral 1 over 3 sine theta all squared times 3 cos theta times dx becomes 3 cos theta d theta. One good thing about substitution is that something must cancel out. So 3 cos theta cancels 3 cos theta, and that simplifies our problem. So we have integral 1 over 9 sine square theta d theta. Now because 1 over 9 is a constant, I can bring it out. 1 over 9 integral 1 over sine square theta d theta. So this looks simple. Again, in trig identity, we have 1 over sine theta as cosec theta. So instead of writing 1 over sine square theta, I'll write cosec square theta. That becomes 1 over 9 integral cosec square theta d theta. Now if I integrate cosec square theta, I'm going to get minus cot theta. So I have over 9 here because I'm multiplying by 1 over 9. Then plus c because we are integrating. So this integral, that is 1 over 9, 1 over sine square theta d theta becomes this. Now let us remember that the problem appears in terms of x. We are going to bring back the form in which the problem appears. Again, cot theta, according to trig identity, is cos theta over sine theta. Now recall that x is equal to 3 sine theta, and therefore sine theta is equal to x over 3. Now, let's also remember that cos square theta is equal to 1 minus sine square theta. And so, cos theta is equal to square root of 1 minus sine square theta. X over 3 is sine theta. Therefore, cos theta is equal to square root of 1 minus x squared over 9. Therefore, cos theta equals to the square root of 9 minus x squared over 9, or cos theta is equal to the square root of 9 minus x squared over 3. Beautiful. Now I will replace this for cos theta in this, and this for sine theta in this, and I will do it up here. So our cos theta is equal to, instead of writing cos theta, I'm going to write square root of 9 minus x squared over 3, then divided by sine theta, which is x over 3. So cos theta equals to square root of 9 minus x squared over 3 times 3 over x. This and this will cancel out, giving us the square root of 9 minus x squared over x. Now finally, the solution to that problem is this, and I'm going to substitute this. Therefore, we are going to get 1 over 9 times square root of 9 minus x squared over x. Let's remember there is a minus there, then plus c. This becomes the solution to this problem. If you find this video interesting, I would like you to help this channel by giving it a thumbs up. There are many other interesting videos in this channel that I would like you to check out. Leave your comment in the comment section if you have another method for solving this problem. The method I use is solution by substitution method, and I use trig substitution in solving it. So if you have another method that is more interesting and perhaps shorter than this, I would like to see it in the comment section. Share this video to your loved ones. Thanks for watching, and see you in another video. Bye.